Hello everyone, welcome to the Open AGI Forum. I'm Eric Wong from CSDN, and today, live from the GOSIM China 2024 in Beijing, we're honored to have Chairman Ros to join us. He's got plenty of legendary experience to share. So welcome, Chairman.
Thank you, very kind and great being here. Thank you for having me.
So please take a brief introduction of yourself first.
So I'm Herman Ros. My background is in AI for autonomous systems and computer vision, machine learning. I spent my PhD working on those topics, like trying to develop, new computer vision systems for autonomous driving primarily. And then, the AI revolution happens with deep learning. So shifted to that and trying to make the most out of that revolution. Shifted progressively to simulation topics, synthetic data. I have been working at the intersection of these topics since, like synthetic data, simulation, machine learning, autonomous systems. So my passion is really bringing and democratizing autonomous systems and hopefully making a world where many people and many companies get to develop and use autonomous systems. That's kind of what I'm doing.
Thank you. So you describe yourself as a strong open source advocate. So could you please start by telling us what's inspired your strong passion for open source?
Yeah, so open source has been in my life since I was like a little kid. I remember back in the day, so I started in computers very early. When I was 6, started programming in BASIC, and eventually when I was around 10 or 11, it was this guy who knew my mother, and he came to kind of like talk to me about computers and computer science and programming, and he was like, he saw that I was using Windows at the time. And he was like, oh, interesting, you're using Windows, but are you familiar with Linux? And I said, I have no idea what Linux is. I was like, maybe you can teach me later about it. What do you mean later? Like I have a distribution of Red Hat in my car. I'll just bring it up. We can start using it. I'm gonna install it for you. That was the beginning. So this guy installed Red Hat in my computer, like remove Windows, and I kind of like fell in love, right? Because it gave me so much power. Like I could do everything with that distribution. I could compile my own things. I could change everything. And since then, I became like a very passionate person about open source. I started, participated in open source forums at universities, etc. Like I remember when I was 16, I started like teaching open source related classes in college to professors and other people, and that's where I kind of like fell in love. There was a huge community around open source. It felt like home, like finally there's a home for me. All these people that also care about open source, and it kind of like became like a family. So that's why I have been so passionate from that day about open source. That's how I started my journey.
Let's move on to questions related to Carla. So Carla started from scratch, and it is now one of the leading autonomous driving simulators. So could you share what was the most exciting part of creating Carla? So was there a moment when you felt we really made it?
Yeah, so in order to understand Carla, I think we have to take a few steps back to understand what happened before Carla. Because what happens like in 2012, 2013, we have the deep learning revolution, and thanks to that, we started seeing that some of the techniques that didn't work were starting to work, right? But those techniques were very data hungry, and you needed to provide annotations. And for some problems, those annotations were super hard to retrieve. I remember that I labeled more than 10,000 images manually at the pixel level, and eventually I say, this is enough. I cannot just spend my life annotating images. This was before like annotation services were common and inexpensive. So we decided to revisit the whole idea of using like game engines and simulation platform to automatically generate data. We created the first platform in that space called Cynthia. Cynthia was like a huge boom, a huge success. In academia, we even license it to industry across OEMs, but it was focused on just perception, training and validation of perception. And then we got the opportunity to kind of like generalize it. Someone approached us and say, would you be interested in doing something like this, but not just for perception, but for the whole problem? And would you be interested in making open source? And I say, this is a dream come true. And that's how Carla started. When we started the journey, we basically have to, as you say, building from scratch. At first, it was very complicated because there was nothing like Carla at that time. And many of the ideas that we brought in were brand new, and we have to discover and design many new things that no one had done before. So we have to go through many different challenges to finally build a platform that the community wanted. And at first it was very basic. During the first year, we actually have to redesign Carla 2 or 3 times, and finally we came up with something that kind of worked. So it was a very challenging time to basically learn the right path by doing and by making mistakes.
Yeah, when I first time saw the Carla, I think you might need to use some technology in the racing game. So you might need find some game engineer to help you.
Yeah.
So in 2016, the Carla projects received funding from Vladimir Kotem and Intel and became a fully open source simulator. So what was some of the difficulties you encountered during the growth of the Carla project, and how did you overcome them?
Yeah, I think Vladimir had this vision that ahead of his time about, this is the tool that the world is gonna need in a few years, and we agree with that vision, and we say, okay, let's work on it. But I think none of us really expected the success of Carla and the adoption that the community had. So that was one of the challenges that, from our perspective, when we started Carla, we wanted to do Carla basically for us. We said, okay, we're researchers in this area, we need this tool, we want to do something that works for us. We didn't expect the community, we didn't expect industry to pick up Carla and say, hey, I want more of this. So that was the main difficulty, that at some point, it just took off. It just had life on its own. And we kind of realized that was much bigger than we anticipated, and it was bigger than us. So we have to we realized that it wasn't like a project that you start and after 1 year you finish and you move to something else. We realized that we needed to keep working on it because it was important. It was something that was very helpful for the world. So we just have to find ways to keep going and keep developing. So we have to start thinking about put together a non-profit organization to keep developing Carla, how to get funding, to have developers and involve the community, and so on. So that was the real challenge, like the fact that it basically grew beyond our expectations.
Yeah, I wonder that how does Carla simulate the street walking? Do you really need to collect the behavior of the people who's walking the street, or would we work on it?
So Carla is very flexible, so you can utilize different ways. For some people, it's very important to really keep very high fidelity in terms of behaviors. So those people definitely are going to use models that are based on real world data. So for which you need to collect real world data. Some people are fine not using so sophisticated models, so maybe they would be okay using models that are rule-based, right? Models that we have designed. So we have a little bit of everything. So depending on your needs and the fidelity that you require for your use case in different domains, you will end up using one model or another. So Carla is very modular.
I see. With your extensive experience in autonomous driving simulation, so could you tell us why you choose this path initially and why you joined the Tokyo Research Institute before?
Yeah, I have always been very passionate about robots. And for me, I saw that the door to robotics was autonomous driving. Autonomous driving was something that was becoming mature enough to have an impact in the world. So that was one of the main reasons to get into autonomous driving. And then when you get into autonomous driving, you realize like, in order to make something successful, you need good tooling. Like good tooling is critical. And some of the key tooling there is simulation. So there was not a lot of good simulation tooling out there. And that's why we kind of have to connect the pieces. We need to create a simulation platform so that we can be good at developing autonomous driving solutions, which was one of my true passions.
I see. Actually, when did you found the path of the autonomous driving? Because your PhD is in computer CV, computer vision, right? So could you elaborate on the connection between CV technology and autonomous driving?
Yeah. So for me, from the beginning, it has always been about how do we put robots out there. For a long time, if you think about the different tasks that you have to approach to have robots out there in the real world, it becomes so obvious that scene understanding is one of the first tasks that you need to figure it out, right? In order to have a robot that navigates the real world, you need to understand very well what's happening around the robot. So that's why I started with computer vision. I wanted to develop the techniques that will allow the robotic vehicle, to actually perceive the real world, understand what's happening, and eventually take decisions based on that understanding. That's why my thesis was very focused on computer vision. It was always with the mindset of, I want to apply it to autonomous driving and robotics, and eventually when this problem is solved, we'll move to solve all the other problems, planning, etc. So that's kind of like the connection.
When did you make that clear? Is it in your school time you already find a way?
Yeah. I think it was basically towards the middle of my PhD that became clear that eventually it wasn't just about computer vision. It was in general for me about like autonomy and robotics, autonomous vehicles, like whatever it takes. If the focus needs to be computer vision, so be it. If the focus needs to be something else like planning and control, let's attack whatever problems need to be solved in order to enable autonomous driving. And I think that happened towards the middle of my PhD.
I see. So in your opinion, what are the most promising future development in the fields of autonomous driving and digital twins? So will we eventually have a digital twin for everyone, every car, that we can manage the twin through our phone or other device? Could that happen?
Yeah, so I think I'm really passionate and a big believer about some of the new technologies such as end-to-end solutions. I think end-to-end is a great democratization technology, because in the past you needed to have a large team of people working on the different problems, right? Perception, planning, control. Now you can have the same people all focus on the problem of driving, right? Like data comes in, you train models that are supposed to be good just at driving. You don't have to divide your attention. I think that's gonna make newcomers to this space to have a way to leapfrog existing companies. So I'm very passionate and enthusiastic about that technology. Another technology that is very close to my heart is neural rendering. So the fact that today you can use neural networks to create representations of the world, and they look like exactly like the real world, where the domain gap has been reduced to pretty much nothing. That's also very, very interesting. I think because of neural rendering and neural reconstruction, we will have actual digital twins of, if not the entire world, of some of the most important regions, and people will be able to create their own digital twins with ease, right? So these technologies are going to become a commodity, and you will not need to be an expert to have a digital twin of your house or a digital twin of your neighborhood. Eventually, everyone will be able to create a digital twin with ease, thanks to these new technologies.
I see. So what does open source bring in the path? So it's like the reason why you choose the topic of open source in the age of embodied AI. Open source simulations in the age of embodied AI.
So I think for me, it's important to realize what elements enable the acceleration of the field and what elements kind of like kill the acceleration, because we don't have robots out there yet at scale. Why not? We need to accelerate, we need to become faster, we need to put things in production faster. And I really believe that open source is a key contributor to that acceleration, especially open source in simulation. I think if you have good tooling out there that you can easily modify and adapt to your business needs, right? If you can make it yours, you are gonna be able to have that acceleration in production. So that's kind of like the glue in my mind that brings everything together: simulation, open source, autonomous systems. Like, we need good tooling to create autonomous systems and embodied AI systems, right? That good tooling needs to be adaptable and extensible. And I think one of the best ways to achieve that is through open source.
In the forum today, Gary Bretski is in the forum today, and he's in front of you, right? So, do you believe open source should receive government support? Because Gary once says, he mentioned that open source should be supported by the government before, because nothing that there is minimal investment from governments despite the significant potential returns. So it seems everyone has different views on open source. Some associate it with non-profit, and some since open source shouldn't connect with the concept itself shouldn't involve fees. So I'd love to hear your opinion, your comprehensive view on open source.
Yeah, it's a complex topic, right? But yeah. I support Gary's view on the government should be more participative in the funding of open source projects, because people who are building open source solutions are doing something that is beneficial for the entire community, right? So there are startups, mid-sized companies, governmental organizations that leverage these open source solutions. So we are doing a huge task for the world. So it is just natural in my mind that the government should be more supportive. So that's my personal stance. So I 100% agree with Gary on this. Now, until that happens, we probably have to find alternative ways to support open source projects, right? Like, everyone is trying different things. Mm-hmm. But it would be ideal if the government will be more involved in the funding of open source.
Given the intense competition among LLM vendors, so there's many voice happening again, the debate between open source and closed source. So this happened again, has ring across the various fields. So what's your take on this ongoing debate between open and closed?
Yeah, I feel a little bit divided in that topic, because on one hand, I'm very passionate about open source, right? Yeah. But at the same time, running a non-profit foundation that works in open source, we see the complications and the hassle of developing open source, right? Like, at some point, you need to find a business model that works. You may have millions of users, but how did you manage to turn that into a way to support the people that are working in the open source project? That's still a challenge today. Many companies struggle because they are not able to convert that traction, that momentum that they have in the community with a large community of users to be able to self-maintain, to maintain the project, right? So that's why we started seeing like hybrid models, like freemium models, or models where you have the source available, but it's not fully open source. If you are using it commercially, you might have to pay a license fee, etc. And it's just because, we don't have a good mechanism for open source maintainers or organizations that develop open source to survive. It's just still very hard, and we have that problem, and we have to come up with different formulas to survive. So it would be great if we could, if the world could see the need to be more supportive with open source, and more people would donate, or more companies that are actively leveraging open source solution for their businesses would participate in the funding. So it's a very complicated problem.
I see. So can you teach the audience how to manage and motivate contributors from around the world to have to keeping an open source project through the long term?
Yeah, I don't have a good answer, right? This learning by trial and error. I believe one of the keys is to attempt to be engaging. Like, you need to listen to the community. It's very important that you find a mechanism to listen to the communities. It could be through, GitHub issues or forums or Discord. You need to listen. You need to be there for them. You need to listen to what they ask. You need to listen to their problems. And then it's important that you have mechanism to engage with them. You need to talk to them. You need to organize activities to bring them together. So I think it's basically like finding ways to have a productive conversation with people. I think that's one of the keys.
So what is your opinion of the combination between AI and open source? So in the rapid age of AI era, so how do the developer and the researcher, so they keep their competitivity and innovative?
It's becoming trickier and trickier, and especially in the US, where now there is new legislation, like in California, asking for AI developers to have, more oversight over everything, over the data that they're using to train the models. You now need an external sort of like moderator to look into your models. You need to go through audits. So it's becoming harder and harder. It's hard for developers, individual developers, to keep up with industry. I think one of the positive things that has happened within industry is that some large corporations have decided to open source their foundational models, like Meta with Llama and many others like Mistral. And I think that has really helped the community to focus on building on top of that, which seems to be working fine. But I think this is gonna be a very dynamic field where the situation will keep changing. It's gonna be tough to keep up for small developers. I hope that we find a way for perhaps governments to provide more support in the form of access to hardware, right, or access to data. I think we really need, in order to have small developers to keep up, we're gonna need some government help.
Great. What is the reason you start osvf.org in the first place? So are there any obstacles to the development to the Omniverse platform? So how are you addressing them?
Sorry, correction. So it's not Omniverse, is Carla. So Omniverse is a different platform.
Yeah, it's a different platform. You mean Omniverse is NVIDIA, right?
Right.
And Carla is your open source project.
Yeah, and OSVF was started to sort of like support Carla and others.
Yeah.
Yes. Yeah.
So there's two questions actually. Two questions.
Oh. So we started the OSVF with Gary Brasky because we were looking for a way to be able to maintain the development of Carla, right? We wanted to have a legal entity that could support them. So that was the main reason to have originally the OSVF. Eventually, we saw that the OSBF was used as an umbrella for OpenCV, Open3D, Carla, and other projects, but Carla started having needs that were very specific, so we split from the OSBF to create our own non-profit organization called the Embodied AI Foundation, that is now the one organization hosting Carla. What was your question regarding Omniverse?
Yeah, the Omniverse, the question is, are there any obstacles to the development of the NVIDIA Omniverse platform? How are you addressing them?
No, I think there are no obstacles for the development of Omniverse. Omniverse is a great platform. It's full of talented engineers working on it. I work in Omniverse too. Right now Omniverse is becoming a set of APIs that everyone can use as part of the simulation platform. So that's great, because now you don't have to compete with Omniverse. You can basically borrow whatever functionality is interesting and useful from Omniverse. We are doing that with Carla, so we are bringing like new capabilities that integrate with the Omniverse APIs, so that people can get access to things like high fidelity sensor simulation through Omniverse. So if you are a Carla developer or a Carla user and want to have access to high fidelity sensor simulation, very soon you'll be able to just leverage the Omniverse APIs to do so. So, things are going well in that front.
I see. So what is your personal challenge in the next few years? Because there's many words today, open source, Carla, and embodied AI. So they're all facing different kinds of challenge. So there's a big topic. So how about your personal challenge?
Yeah, I think I have a few. So I think with the mindset of how do we bring embodied AI into the real world soon, we need to solve many different problems. One problem is, how do we make sure that the right simulation tooling and other type of tooling is in place? And for that, one key question becomes, how do we make a business out of it? So if we cannot find a good business model around simulation tooling, it's going to be very hard to keep those tools to be useful and up to date and state of the art. So that's one of the key problems that we need to figure it out. Good business model that can cover the open source angle, the commercial angle, and help these tools to keep evolving and sustain through time. That's one of the main issues that I'm looking into these days.
I see. Actually, this issue we can avoid is that, as someone who has been deeply involved in the development of AI technologies, what are your thoughts on the ethical implications of deploying AI-driven robots in public spaces?
Yeah, it's a very sensitive topic, right? Because when you put robots in the real world, bad things can happen. It's not like when you have something that operates in the web. So it's very important that we take the topic of safety very seriously. I remember when I started at Toyota Research that I care mostly about putting things in production and coming up with new agents that we're doing better and better. And I think at the time I didn't think about safety as this super key topic. I knew that it was somehow important, but I couldn't interest it until things started happening. The Uber accident, the sometimes you have your new version of your stack in the vehicle, a safety driver is there, and he or she goes into some troubles. And it might be because of you, because those changes that you were doing. You realize, this person who happens to be my friend could be in troubles because of me. Then you start realizing this is a very serious business. So I think it's imperative for companies, developers, to really consider safety first. That's the ethically responsible thing to do. And for that, it's very important to come up with strong validation and verification protocols. We need to have a strong plan for validation and verification, no matter what is the embodied AI solution that you are deploying. We need regulators, we need third parties that are involved and are giving you like an independent evaluation of your platform to guarantee that things are fine. So the more eyes we can have on top of these products, the better. We need more eyes, and we need to take safety very seriously.
You know, after the Tesla robotaxi, after that news, everybody just mentioned that it's really coming. So we must put on the security problem. So can imagine various number of when can we see the auto taxi or autonomous driving car on the road?
Today. So for example, so where I live in Bay Area in California, Waymo is already deploying robotaxis, right? So I have taken many Waymo vehicles to move throughout Bay Area. It's great. It works great, and we're gonna keep seeing more of that in different cities. So what we call L4, right? So basically, robotaxis that work well within a region, a geographical region. And it will not be just from Waymo, so we're going to see this vehicle from Cruise, we'll see vehicles from Tesla, and many other vendors. So this technology is here today. I guess the question becomes, when are we going to see it everywhere?
Yeah.
And that's going to take a long time. It's going to be a slow process. And because people are trying to be very careful. Because you make one mistake out there, that changes public perception, that changes how the government see your mission and your company, and everything can evaporate overnight, right? So that's why it's taking longer to see the adoption in different cities, because every new city, every new mile that you add, you need to be very careful. One mistake and everything could go away.
GOSIM, the 5 letter, it stands for Global Open Source Innovation Meetup. So there's still an innovation of the questions. So as a leader in technology, what strategic decision have you made that you feel were pivotal to the success of projects or companies you have been involved with? So how do you navigate the complexities of aligning business goals with tech innovations?
It's definitely a challenging problem, right? So I basically try to be very connected to the research that happens in the world, like very active, talking to professionals in academia and industry, trying to understand what are the new technologies and ideas that are emerging in the research field. Trying to really be data driven, like, okay, is this gonna work? Is this gonna work at the scale? So we'll be transitioning to this type of technologies. You need to run the experiments in order to be able to have an opinion, or you need to have access to someone who has run the experiments and collected good data. So that's kind of like how I try to proceed. So being connected to research, being able to have access to data to try to make educated decisions. And then, sometimes you have to take risks, you have to bet for some technology, see if it works from a business standpoint. Yes, sometimes it's a matter of time. So time tells you if something is gonna work or not. Sometimes great ideas don't work because maybe it's not the right time, it's too early, it's too late. So you have to believe in something, and you have to try it out and see how it goes. Put it out there in the real world, talk to people, gather feedback, and then keep iterating.
Yeah. That question is because I want to ask, in your mind, is there any applications of open source simulations that haven't come up but might come up in the future?
So I think simulation is so broad, right? Like simulation really means, in my mind, querying the world as a service, or turning the world into a computational model where you can launch any query that you want. So right now, simulation platforms can answer some queries right? That are related to, creation of sensor data or some basic physics. As simulation keeps evolving, we're gonna be able to do more and more complex things. We're gonna be able to simulate physics in ways that are more accurate. We're gonna be able to simulate sensors and how the light and electromagnetics will behave. And eventually, that's gonna serve us to basically, create very powerful AI models in many different domains. So I'm thinking how simulation can help in topics and domains such as space exploration. Like we are working with NASA today to help them figure it out how to develop new habitats on the moon, or how to have autonomous systems that can create those habitats. But they cannot really send people up there in a daily basis to start running experiments. So simulation is helping there. The better simulation technologies become, and the better we can simulate Earth in high fidelity and other planets, the more application we enable, because then you can turn everything into a computational problem. You can basically just start applying computational techniques to discover new ways to do autonomy on the moon, or new ways to unfold proteins, right? So simulation, as it evolves, is going to enable applications that we haven't even conceived yet.
Yeah. So actually now we can see many startup of autonomous driving car companies. So can you share some advice for researchers and developers to better embrace their careers in the AGI era?
I mean, it's really hard to provide advice, because we're living through such a tremendous innovative times, right? Everything's changing every day. But I would say, be aware of the tooling that is out there, right? Be aware of how to use simulation solutions as part of your workflow, because they can really give you an edge on developing innovative solutions. So know your tooling, master your tooling, and keep using simulation to keep making progress fast. That would be a small piece of advice.
I see. There's a lot of questions. Thank you.
Thank you very much.
Thank you very much. So thank you, Herman, for the insightful discussion. And thanks to all the developers watching. That's all for today's podcast. So see you next time.